So today we're going to be going over compounding interest part 2. So we've gone over previously about how compounding interest, we talked about if we increase that rate, if we take a lower percentage, maybe not 1% a year, but maybe if I take 0.5% twice a year or 1/3% 3 times a year, we make more money because we have more opportunities for our interest to make interest. So let's see, if we expand that logically to infinity, which at the end of the last video we started with Euler's discovery, we set the limit as n approaches infinity of 1 plus 1 over n to the n. Let's see what we get. So if I compound that once, 1 plus 1 over 1 raised to the 1, or 1 plus 1 over 10 raised to the 10th, 1 plus 1 over 1,000 raised to the 1,000. And because apparently I can't type, let's just add another 0 so it, there, looks better. 1 plus 1 over 10, 1,000 raised to the 10, 1,000. We're going to notice that n is approaching some number. And so we know that this number is 2. We notice that this one, if we take a gander, and you already see that what we're going to be going for here. So 1 divided by 10 plus 1 raised to the 10 is going to be 2.59374. 1 divided by 1,000 is going to be 2.71692. 1 divided by 10,000 plus 1, 1, 10,000. Notice we get 2.71814, and that 4 actually rounds up to a 5. The idea is n approaches infinity, we approach this thing called Euler's number. Which Euler's number? On most calculators, you'll have a pi, you'll have an e and an I. E is the biggest thing, is going to be 2.71828, Euler's number. And so we're going to rearrange our equation a little bit into this. The amount that we get after a year, if we put our money in and allow it to compound infinitely, so every moment of the day it's earning interest, and that interest is earning interest, we're going to multiply that money times e raised to the rate over time. And so let's take a look at how that works. So if I have $1,000, that's my principal, at a 5% rate, so 0.05, annual rate over 6 years. My time is 6. I could actually plug that in and say the amount I get back is going to be equal to 1,000 times e to the 0.05 times 6. So e raised to the 0.05 times 6 times 1,000. We would have $1,349.85. Don't forget, we always round in the bank's favor because they don't round up. And we're going to go through a few here where we're going over the same thing. The first thing we're going to run into is we notice that even with continuously compounded interest rates, we have annual rates and monthly periods. So all we're going to have to do is we're going to take our $4,500. We have 2% annual over 6 months. So time is not going to be 6. In this case, time is half a year. If it's 2% annual, half a year, boom. So the amount we get back is $4,500 times e raised to the 0.02 times 0.5. Let's see what we get. So e raised to the 0.02 times 0.5. We get that times the $4,500 investment. We get $4,545.22. Cool. So you kind of get the trick. So we've got a few other questions built in right here. Why don't you pause the video real quick, give these a shot, and see how well you do. Okay, so assuming you've paused and you've given these a shot, most of what we're lining up here is that if I have 7% monthly, so 0.07 over 2 years, well, I'm going to have to multiply the number of months in the 2-year period. My time is going to be 24. 10. So the amount I earn is 10,000 times Euler's number raised to the 0.07 times 24. So Euler's number raised to the 0.07 times 24 times my initial $10,000 investment, which is $53,655.55, almost 56. If I had a 1% daily, my $1 at 1% over a year, well, that's going to be my time is 365. So $1 times Euler's number raised to the 0.01, 365. Boom. We'll have $38.47. It's actually not bad. I'll take 1% daily over a year. 7% fortnightly. Fortnightly, every fortnight is 2 weeks. So you could also call it biweekly over the course of 3 years. Principal is $21, 0.07. How many 2-week periods are there in 3 years? Well, I know there's 52 weeks in a year. So times 3 years, 156 weeks over that 3-year period, divided by a fortnight. So my time is 78. Oop. This amount equals $21 times Euler's number, 0.07 times 78. Euler's number raised to the 0.07 times 78 times my $21 investment. Ooh, not bad. $4,937 and almost 5 cents. Boom. There we go. So let's put that into practice by saying, okay, how much would your account hold if you invest $100 at 5% annual, continuously compounded over 9 years? So we know in this case, our rates line up. So I'm going to have the amount that I'm going to earn is going to be a $100 investment times Euler's number raised to the 0.05 times 9. 5% annual, 9 years, and they line up. I don't need to do any sort of multiplication. So I'm going to take Euler's number, raise it to the 0.05 times 9. Get that. I'm going to multiply it times my $100 investment. So the amount that we earn will be $156.83. Boom. And now there's another way that we could ask, is we could ask the question saying, if Centurion Bank offers 5% annual rate for continuously compounded, if you do not withdraw your money for 5 years, how much do you have to place in the account to have $2,000 when the term is up? So many savings companies or many savings institutions offer this type of language saying, hey, we'll give you this rate if you leave the money with us for 5 years, meaning you don't take it out. You can't early withdraw. So if you want to, let's say at the end of 5 years, you want to have $2,000 in your pocket, if given this rate, how much would you have to put in? Well, in this case, given our equation, A equals P to the ERT, we know what we want to have at the end. We want to have $2,000, but I don't know what my initial investment is. I know what my rate is, so 0.05, and I know how long I have to leave it in there. Let's see, annual and years. I can just go ahead and multiply this by 5. They already match. So if I want to solve for P, what I'm going to have to do is get rid of this times Euler's number. So I'm going to divide that by 0.05 times 5. E 0.05 times 5. And that's going to get rid of those two. So now in this case, my P is going to be whatever this evaluates out to. So let's see. If I have Euler's number raised to the 0.05 times 5, I have that. I'm going to take $2,000 and divide it by that number. I need to put in $1,557, and in this case, probably the extra penny, because I want to have at least $2,000. So I'm going to say $1,557.61, just to be sure. Awesome. Okay. And so we have 2 more questions. Why don't you go ahead and give these a shot? These are a little more challenging. And unpause the video when you see how well you did. Okay. So assuming you've given these a shot, Flarkin Federal guarantees that you can be a millionaire using their 25-year, 10% annual rate for a continuously compounded retirement account, as long as you meet their minimum deposit requirements. Shiesty Flarkins. What's the minimum balance required to make this claim? So you want to be a millionaire in 25 years. So we know the amount that we want. We want to have $1 million. I don't know what amount we need to put in. I know that I'm going to have to continuously compound this at a rate of 0.1. Let's see, an annual rate for 25 years. I can just go ahead and keep these 2. Actually, those are my RT. So if that's $1 million, what I'm going to have to do is I'm going to have to take $1 million and divide it by that number, because that's going to cancel those out. So the amount that we put in is going to be 1 million divided by Euler's number raised to the 0.1 times 25. Which is equal to a lowly, oh, no, that's Euler's number raised to the 25th. I was going to say, if we only had to put in $12, that would be amazing. So 1,000 million. We're going to divide it by that number. It's a little more realistic. So $82,084.99. So we're going to round that up to $82,085.00. Awesome. And so for the second one, you have a bill with Jackson's face on it, and you deposit into a 3% annual account that compounds continuously. After 50 years, you withdraw the entire sum. How much do you withdraw? So in this case, we don't know our A. We know a bill with Jackson's face. Let's see, that's going to be a $20 bill. I know that we get 3%. And this is an annual rate at years. So I can just multiply that by 50. So E raised to the 0.03 times 50 is going to give me that. So 20 times 4.48, without clearing it, times $20. We're going to have $89.63. There you go.